Hello everyone, you are welcome to solve this nice algebra problem, which is x times x, which you can express as x to the power 2, divided by 5 times 5, which is 5 squared. This is equal to 5 times 5, which is actually 5 to the power 2, over x times x, which is x to the power 2. The next step here, let's cross multiply here. So we have x to the power 2 times x to the power 2. This is equal to 5 to the power 2 times 5 to the power 2. So this implies that if you have a to the power n times x to the power 2 times x to the power 2, this is in the form of a to the power n times a to the power m, which we can express as a to the power n plus m. Applying this exponent property, then here we have x to the power 2 plus 2. This is equal to 5 to the power 2 plus 2. So this implies that here we have x to the power 4. This is equal to 5 to the power 4. Now, let's take 5 to the power 4 on the left hand side so that we have x to the power 4. Subtract 5 to the power 4. This is equal to 0. We can express x to the power 4 as x to the power 2 raised to the power 2. Subtract 5 to the power 4, which you can express as 5 to the power 2 raised to the power 2. This is equal to 0. Now, this equation is in the form of a to the power 2 subtract b to the power 2, which we can express as a plus b, then a minus b. From this equation, we have a equal to x to the power 2, and we have b equal to 5 to the power 2. So this implies that a plus b, this is equal to, now x squared plus 5 squared, this is equal to 0. Let's call this equation 1. And we have a minus b, this is x to the power 2, subtract 5 to the power 2, this is equal to 0. Let's call this equation 2. So let's start to solve equation 1. So let's start with equation 1, which you can call case 1. Now in case 1, we have x to the power 2 plus 5 to the power 2. This is equal to 0. Now this is actually in the form of a squared plus b squared, which we can express as a plus bi, then a minus bi. So this implies that x to the power 2 plus 5 to the power 2, we can express this as x plus 5i, and then here we have x minus 5i. So this is equal to 0. So we have two parts here. The first part is x plus 5i. This is equal to 0. The second part here is x minus 5i. This is equal to 0. So the first value of x here, that is x1, is equal to minus 5i, and x2 here in the second part here, minus 5 you take to the right hand side, so this becomes 5i. So we have x1 and x2. Let's proceed to case 2 now. In case 2, we have x to the power 2, subtract 5 to the power 2. This is equal to 0. Now, this equation is in the form of a squared minus b squared, which we can express as a plus b, a minus b. So this implies here we have x plus 5, and here we have x minus 5. This is equal to 0. So we have two parts here. We have x plus 5. This is equal to 0. And we have the second part here, which is x minus 5. This is equal to 0. So this implies that we have x3 equal to minus 5. And we have that x4 is equal to 5. So from here, we have 4 solutions. So let's verify that these four solutions actually satisfies the equation. So here we have four solutions. We have x1 minus 5i, x2 5i, x3 minus 5, x4 5. So let's verify that these four solutions satisfies the equation. Now, if you recall here, we have that x over 5 times x over 5, this is equal to 5 over x times 5 over x, which we simplify here to x to power 4. This is equal to 5 to power 4. Let's substitute the first value of x, that is x1, which is equal to minus 5. Let's substitute this. Now, this implies that we'll have minus 5. This is 5i raised to power 4. This should give us a value of 5 to power 4. So in this case here, we have minus 5 times I times minus 5 times I times minus 5 times I, then times minus 5 times I. This should give us a value of 5 to power 4. So minus 5 times minus 5, this is actually equal to 25i squared, then times minus 5 times minus 5. This is actually the same thing as 5 squared times I squared. This should give us a value of 5 to power 4. So we have that I squared, this is the same thing as minus 1. Substituting this, we have, this is 5 to power, 25 is the same thing as 5 to power 2 times this 5 to power 2, then times I squared, which is minus 1, times I squared minus 1 again. This is equal to 5 to power 4. So 5 to power 2 times 5 to power 2, this is 5 to power 4, and this is equal to 5 to power 4. So this implies that the left hand side is equal to the right hand side. So x1 satisfies the equation. So let's check x2. x2 is equal to 5i. So this implies here we'll have, remember we have x to power 4 should be equal to 5 to power 4. So this is 5i to power 4. This should be equal to 5 to power 4. So this is the same thing as 5i times 5i times 5i times 5i. This should be equal to 5 to power 4. So this implies that 5 times 5 here, this is 5 to power 2, times I, this is I to power 2, then times 5 times 5, this is 5 to power 2, then times I, this is I squared. This is equal to 5 to power 4. So 5 to power 2 times 5 to power 2, this is 5 to power 4, times I squared, this is minus 1, times I squared, which is minus 1. This should give us a value of 5 to power 4. So clearly here, minus 1 times minus 1, this is 1. So we have 5 to power 4. This is equal to 5 to power 4. So this clearly shows that the left hand side is equal to the right hand side. So let's check x3. x3 in this case is equal to minus 5. So this implies that we have minus 5 raised to power 4. This should be equal to 5 to power 4. So this is the same thing as minus 5 times minus 5 times minus 5 times minus 5. This should give us a value of 5 to power 4. So this is minus 5 times minus 5. This is 5 to power 2 times minus 5 times minus 5. This is 5 to power 2. So this should be equal to 5 to power 4. So this implies that we have 5 to power. This is 5 to power 2. 2 plus 2. This is 5 to power 4, which is equal to 5 to power 4. So this clearly indicates that the left hand side is equal to the right hand side. So let's check x4. x4 in this case is equal to 5. So this implies that x to power 4, which should be equal to 5 to power 4. Substituting x, we'll have 5 to power 4. This is equal to 5 to power 4. So this clearly shows that the left hand side is equal to the right hand side. And this proves that x4 satisfies the equation. So we have that the four solutions satisfies the equation. We have that the four solutions here satisfies the equation. That is x1, x2, x3, x4 satisfies the equation. So we have two real solutions and two complex solutions, of which all satisfies the equation. So kindly follow the steps, like this video and subscribe. Kindly like and subscribe. So see you in the next video. Bye bye.